we have determined whether CHClO is an ionic or molecular compound and draw an appropriate Lewis structure. So, CHClO. All right. So, is it ionic or molecular? And then draw Lewis. Okay. So with this, we can actually answer whether it's ionic or molecular fairly straightforward. Do you see any nonmetals? Well, carbon, hydrogen, chlorine, and oxygen are all nonmetal, 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 and hydrogen over here, nonmetal. Okay, so all these are nonmetals. Now, do you see any metals? Well, no. So this would actually just be a molecular bond, well, a molecular compound, because there's no metals present. There's no metal ions. Okay. Now let's draw the Lewis structure. Okay, we have CHClO. So first we find out the specifically the amount of electrons each contributes. Carbon being on the 14th column, and also the electron configuration being 2s2 2p2. It supports that it only gives 4 electrons to this. Hydrogen is just 1s1, so it only gives 1 electron. And I'm getting these numbers for electron configuration based on the row, based on the column they're in, and also the row. But chlorine is down here, the 17th element. Okay, so if we count through, we start from the most recent noble gas, and then it'll be 3s2 3p5, which also supports that chlorine has 7 valence electrons to work with. And oxygen, the last one, okay, start at helium because it's close to that carbon, and 2s2 2p4. All right, so that means oxygen has 6 electrons to give. So in total we have 4 plus 1 plus 7 plus 6. And we get 18. So we're working with 18 electrons. Alright? And because carbon, okay, is kind of like the best one to work with because it has 4 lone electrons, it can form pairs with each of the electron. We'll put that in the middle. So we have C right here. Alright? And this is where it gets a little bit tricky, because we want it to be, ooh, yes, I'm going to CHClO. I'm really thinking about this one because I believe, let's start like this. You know what? Let's just continue with our gut. Okay. So it's gonna have Cl. Oh, there's only 3 things. Wow, I'm really bad at counting. No wonder I was panicking. Good. That makes things a lot easier on my head. So Cl, H, and O. And chlorine, as we said, it likes 7 in its valence electrons, and it's only sharing 1 of its 7. So 2, 3, 4, 5, 6, 7. Hydrogen is already sharing 1 of its 1. Oxygen is sharing right now 1 of its 6. So 2, 3, 4, 5, 6. And carbon is sharing, actually let me draw like this. Carbon is sharing 3 of its 4 right now, okay? So it's 3, 4. So what's going to happen here actually to be able to satisfy this octet rule and just work with each other, these are going to form a double bond, okay? So now what we have as a picture for a Lewis structure is carbon, chlorine, a double bond here for the oxygen, and whoops, no longer here, the hydrogen right here, Then we fill out the valence electrons, okay? And then we are done there, okay? So now, with this all being said, okay, we're going to now figure out the theoretical charge of each one. So chlorine has is going to be like 7 valence electrons. Subtract, it has 6 electrons by itself and is bonded, sharing 2 more. So that's why you divide it by 2. That does equal 0. The carbon in the middle, 4 valence electrons, it has 0 by itself and is sharing 8 of them. So that's also 0. So that's perfect for the theoretical charge. Oxygen, 6. Okay, it has 4 by itself, is also sharing 4. So that's also 0. So it's perfect. And hydrogen, it's 1 and it's sharing 2. So all these are perfectly balanced. This right here is the Lewis structure for CHClO. Okay, and it'll look like this with bonds. Okay, with carbon in the middle, Cl, oxygen, and then hydrogen right there. That's what that would look like with just the bonds. But yeah, this would be the Lewis structure of that. Okay, exactly. So you see here, 4, 1, 7, 6, 18 valence electrons, and this is what we get. A double bond where the oxygen is, single bonds everyone else, and CHClO is a molecular compound because of the fact that there are no metals there. Okay, so now question number 11.